Hello everyone, I am Kalai Selvi, Assistant Professor, RMDEC Engineering College. As per our syllabus, this is the portion for Unit 2, Heuristic Search Strategies, Heuristic Functions, Game Playing, Max Algorithms, Optimizations in Game, Alpha Beta Search, Monte Carlo Search, for games, constant satisfaction problems, constant propagation, backtracking search for CSP, local search for CSP, and structure of CSP. Memory bounded algorithms. So memory bounded algorithms have two types, recursive best first search and memory bounded algorithm with A star algorithm. So MA star. The performance value for recursive best first search is an optimal algorithm if the heuristic functions is the admissible. Heuristic function is a logical way to solve a problem. For example, you take a tic-tac-toe game. If you suggest all the possible ways for an X to move, we are putting X and moves, right? So the if you are checking all the possible ways, then the probability of the states will be high. To reduce it, we will be think in a logical manner that we say it as a heuristic manner. So the h of n value will get reduced. So it is used to reduce the space complexity and logic complexity, time complexity. So its time complexity rather difficult to categorize. So it depends both on the accuracy of the heuristic function and how often the best path changes as nodes are expanded. Difference between RBFS and IDA star. So ID means iterative deepening A star algorithm. So here this A star algorithm between the iterations retains only a single number. So the current F cost limit. RBFS retains more information in memory, but it uses only linear space. Even if more memory were available, RBFS has no way to use it. IDA star and RBFS suffer from using little memory because they forget most of what they have to done. Both algorithms will end and re-expand the states many times over. So this is the major difference between RBFS and IDA star. Memory bounded A star algorithm. So in order to use the full available memory, two algorithms we have devised. So under that A star memory bounded A star, we have simplified A star and memory bounded A star. In simplified A star algorithms, this proceed like a star, but the best leaf will be expanded until the memory is full. Start without expanding all the possible leaves from a state's space tree, only the best leaf will be expanded. At this point, we can add a new node to the search tree without dropping. We can say it without pruning an old one. So simplified A star algorithm will always drop the burst node, that is, which node is not used for a long time, that node be will be deleted automatically. So the one which has the highest F score, we can say that node will be the worst node and it will be dropped. So like RBFS, SMA star, simplified memory A star algorithm, you have the backup value for the forgotten node to its parent. So in this way, can able to see the ancestor of forgotten subtree and knows the quality of the best path in that subtree. It also generates the subtree only when all other paths have been known to the known and it is shown as it's not a worst path. To avoid selecting the same node from deletion, so we can expand the newest subbest leaf, and also you can delete the oldest non-usable leaf node. If that particular leaf node is not a goal node, then if it is not on a optimal solution path, that is, we cannot able to reach the solution within the available memory. So this is the major disadvantage of a simplified A-star algorithm. Performance valuation. So the metrics you will be calculating for any algorithm will be completeness and optimality. So SMA star is optimal and it is reachable to its goal state, and we can say it's complete if there is any reachable solution. That is, if D is the depth of the shallowest goal state, it is less than the memory size. Compared to RBFS, SMA star is far best comparatively to RBFS, because the state space is a graph, step costs are not uniform, and no generation is expensive compared to the overhead of maintaining the frontier and explorer state. Meta-level state space. So each state in a meta-level state space captures the internal state of your program, that is searching in a object-level state space such as Romania. Object-level state space of A-star algorithm consists of current state search tree. Each action in meta-level state space is a computation step that alters in the internal state. So, for example, each computation step in A-star expands a leaf node and adds successors to the tree. This is an example of a 8-puzzle game. So to achieve initially this will be the start state and this is the goal state. So we have to move these tiles so that we have to go get this goal state. Now we are going to see the heuristic function that ranks as an alternatives in various search algorithms at each branching step basing on an available information in which order to make a decision which branch is to be followed during the search. Thank you.